Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is area enclosed by polar curves. Sometimes we are interested in determining an area enclosed by a polar curve. R is equal to f of theta. First, recall that a sector is essentially a slice of a circle. Am I right? Imagine that this is a sector. If you draw a circle, this is just a piece of the circle. Am I right? That is nothing but a sector, which is a slice of a circle. And it has an area. What would be the area of a sector? 1 over 2 r square theta. Am I right? So in this video, we are going to look at areas enclosed by polar curves. Please note that we said enclosed by instead of under, as we typically have these in the problems. So we are going to work out these problems a bit differently than the other areas. So I'm going to sketch a figure so that you can understand how it will look like. Consider this graph. We are going to looking for the shaded area in this sketch. So what is the formula for finding the area? Yes, we are going to use the same area of a sector here with an integration symbol. So this is from alpha to beta and this is the R value. So the area formula is going to be, do you see the formula? Yes, 1 over 2 r square integration alpha to beta d theta. Please notice that I'm using r here in the integral instead of f of theta. So please make sure and substitute accordingly when you're going to do the integral. So it depends upon the R value, the function they are giving in each of the example. So this is all about the introduction for the area enclosed by polar curve. Now let us take few examples and discuss how to find the area that is enclosed by the polar curve step by step. Here is the first example. Determine the area of the inner loop of r is equal to 2 plus 4 cos theta. So in this topic, under this topic, area enclosed by polar curve, you may get graphs that are very different from the other topics. Mostly you'll be getting some loops and all. First, let me draw the graph for you. In most of the questions, you'll be getting the graph directly. You may not need to draw your graph on your own. Here is the graph for this function r is equal to 2 plus 4 cos theta. We graph this function back. You may also have seen these types of graphs in the polar coordinate topic. So for this example, we are going to know the values of the theta, where the curve goes down through the origin. So we can get these by setting the equation equal to 0 and solving for theta. Okay. So if you set this equal to 0, subtracting 2 from both these sides and dividing the entire equation throughout by 4, we will get, you can simplify it further. So cos theta is equal to negative 1 over 2. I'm just going to swap the sides. We need the value of theta, so I'm going to take cos inverse on both these sides. So theta is going to be cos inverse of negative 1 over 2, which is nothing but 2 pi over 3 and 4 pi over 3. Am I right? Even if the graph is not given, you need not worry at all. You are just going to set this equation equal to 0. I mean r is equal to 0. So after setting r is equal to 0 and solving for the theta, you'll get the values. This is where you're going to draw the curve that goes through the origin. So here it is. Does this make sense to you? So in case if the graph is not given, you need not worry at all. And then just shade the inner loop. You are going to find the area enclosed by this curve only. Can you see why we needed to know the values of theta where the curve goes through the origin? Yes, these points define where the inner loop starts and ends. Hence, we can also see the limits for the integration in this formula. So, in this formula, we need to find alpha and beta value. These are the values alpha and beta. So, just plug in alpha and beta. R value is this 1 over 2 is just in the formula and you can find the integration. Okay, let us see that step by step. Here is the formula to find the area enclosed by the polar coordinates. Now let us plug in alpha and beta we just found. You can replace alpha by 2 pi over 3 and beta by 4 pi over 3. 1 over 2 is as such and replace r by the given function. Please make sure that you mention the square. Are you clear with this step? Okay. Now you can just expand this. So how can we expand this? It is of the form a plus b the whole square. Am I right? So you can just use a plus b the whole square formula. A square plus b square plus 2ab. So use that formula to expand this. Are you clear with this step? Now just multiply the half. Half times 4 everything. You just multiply all the terms within the parenthesis by half. Also you can replace cos square theta by an trigonometric formula, which is 1 plus cos 2 theta. Am I right? So you can replace this and take the half inside the parenthesis, so that you can split the integral separately and take the integration and apply the upper and lower limits and find the final answer. I have distributed 1 over 2 throughout the parenthesis. Now I'm just going to replace cos square theta by 1 plus cos 2 theta, which is the formula. Hope you're clear with this step. Now as usual, you can take the integration for each and every term. So I'm getting 8 over 2 is 4 there. To make the calculation simple, you can also distribute this 4 within the parenthesis. So 4 times 1 is 4 and 4 times this. After getting the 4, you can combine that with the another constant 2, which is already there. Are you clear with this step? Okay, now let's take the integration. After that, we can use the limits. Are you clear with this step? Okay, you can also divide this and change this into 2. Now it's time to apply the limits, upper and lower limit. So this one is 4 pi over 3. First plug in, replace all thetas by 4 pi over 3 and then include a minus sign and then plug in 2 pi over 3. After that, I'm going to use calculator for this. You can also solve this one manually. So I'm getting 4 pi minus 6 root 3. Even if I plug in the value for pi, I'm getting 2.174 as the final answer for this one. That's it for this example. This is how we find the area of the area enclosed by the polar coordinates. We just followed the integral to complete this work. Am I right? Okay. So that's how we determine the areas that are enclosed by a single curve. But what about the situations like in case if we get a sketch where we wanted to find the area between two curves? Okay, let me take that question as an example. Please look at this graph. So in case if you get graphs like this, you can use the same formula to find the area which is enclosed by both. And what will you do in case if you're going to find the actual area? Actual area is nothing but difference between the two, r theta, r0 and ri. Okay, let me write a formula for that too. Here is the formula to find the actual area. Just find the difference. Formula is very similar to the area enclosed by a polar curve formula. Okay, let's take an example. Here is the next question. Please read the question once. Determine the area that lies inside r is equal to 3 plus 2 sine theta and outside r is equal to 2. So here is the sketch of the region that we are after. Please have a glance over this. First, we need to determine the area. For that, we will need to know the values of theta for which the two curves intersect. Please notice that the two curves intersect. We can determine these points by setting the two equations because the left side of the two equations are same. So you can set the right side of the equations equal. So 2 replace r by 2. 2 is equal to 3 plus 2 sine theta. Then you can solve for theta. Subtract 3 from both the sides and divide both the sides by 2. So you'll be getting sine theta equal to negative 1 over 2. In case if you're taking sine inverse on both these sides, you'll get the value of the theta. So theta is nothing but 7 pi over 6 and 11 pi over 6 in this example. Let me add these angles in the figure. So I'll get, here it is. Note as well here that we also acknowledge that another representation for the angle 11 pi over 6 is negative pi over 6. So this is very important for this problem. In order to use the formula that we generally use for the area under this topic must be enclosed as we increase from the smaller to the larger angle. So if we use 7 pi over 6 to 11 pi over 6, we will not enclose the shaded region, shaded area. Instead, we will enclose the bottommost of the three regions. However, if we use the angles negative pi over 6 to this region, negative pi over 6 to 7 pi over 6. We will enclose the area that we are after. So I'm just going to plug in everything in the formula and simplify. Replace alpha by negative pi over 6 and beta by 7 pi over 6. We are going to use the second formula. So replace r by r0 square minus ri square, where r0 is 3 plus 2 sin theta and the region outside r is equal to 2. So we are just going to subtract those. Hope you are clear with the step. All you are going to do is a plus b the whole square formula. After expansion, then combine this constant. 2 square is 4. After combining, distribute 1 over 2 within the parenthesis. You have to multiply 1 over 2 for all the terms within the parenthesis. And then take the integration, plug in the upper bound and subtract after plugging in the lower bound. And finally, you'll get the answer after simplification. Very similar to the previous example. Calculation part is going to be very easy. For this problem, I'm getting 24.187. Please try the steps and check whether you're getting this answer. We can see more examples under the same topic in our next video. Hope you're clear with this video. In case if you get any query regarding this video, please let me know. See you in the next video.